Good. Patrick, the stage is yours.
Awesome. Okay. Hello, everyone. Welcome to the webinar hosted by Data Vault Builder. I work for Snowflake. This is my profile over here. So I've got a bit of experience in the Data Vault data architecture space, unfortunately, already over 20 years of it. So a little bit of social things I get into. Definitely the Rugby World Cup, which is really good because we're in the final. How we beat England, I have no idea, but we're there. Anyway, we'll jump straight into it. What we're going to do is go through or quickly go through what the Snowflake architecture is all about, and especially the components that sort of support this sequence number point in time tables that we've put together. Define where the problem statement came from and how the idea came about, and how it relates to existing Data Vault PIT table structure. So anyway, Snowflake is the data cloud platform. It was built from the ground up to be native on cloud. So there's never been an on-prem Snowflake solution. It's basically taking the components that make sense to support a data cloud and wrapped it into really clever architectural code around its proprietary storage, the way it does concurrency, the way it wraps virtual machines in the cloud to run queries and do caching, and supports all sorts of use cases. And then that's been proliferated around the world through deployments on platforms like AWS, Azure, and GCP. So a little bit about what's in the box. Very optimized, flexible storage. Snowflake comes with its own native storage type, which is broken down into micro-partitions. Everything is encrypted at rest, hyper-compressed. And we've also recently announced what's going into public preview, and GA coming soon is support for Apache Iceberg tables, even controlling or rather managing the catalog within Snowflake itself. We also support connecting to on-premise storage through S3 compliant storage like Dell does it, and Pure Storage does it as well. I'm sure there'll be more. A little bit about the compute. As I said, it's actually Snowflake wrapped virtual machines in the cloud. The benefit of that is if you have multiple, let's say, departments, workloads, they are isolated into their own virtual machines. So all of it's concurrent, none of it's interfering with each other. So the performance you get out of one virtual warehouse will be the same as another virtual warehouse running on the same platform. Running through this really quickly because I want to get to the meat of the presentation. I have to mention that we've also introduced SnoPITs, so that it gives you the ability to run Python logic, Java, Scala out of the box. And also with what was announced at Summit is the capability of running your own packaged application within SnoPIT containers, which is also going public preview soon, GA probably in next year sometime. Also, of course, native governance, dynamic masking, row access policies, everything's encrypted. The rest, the Snowflake platform comes with a lot of the expected governance that you want for your organization, for things like regulatory compliance and so on, and basically to deal with things like hiding personally identifiable data. And of course, like I said earlier, Snowflake deployments are global on existing AWS and Azure and GCP infrastructure, meaning that you can deploy your account in one location and replicate that content seamlessly to another location, which Snowflake also provides the capability to do that through replication. Or if you want to do business continuity, also Snowflake supports that you can, tick-tock between production and backup instances of your Snowflake account. And all of that is put together to support our key workloads. data lakes, data warehousing, data engineering, cybersecurity, AI, ML is a big use case now. Native applications is also something that's coming up out of the Snow Day that's going to be announced as well. A lot of collaboration, and Unistore, our new functionality that's coming out soon that combines OLTP and OLAP tables into a single structure that you can now query in place and easily join to existing Snowflake table and external tables, and with the native governance capabilities sitting on top of that querying or engineering capability. So all of that aside, straight into the problem statement. So this, in fact, came up a few years ago. Snowflake was really gaining traction amongst the Data Vault community. So within Data Vault Alliance, they had an older version of the current forum that you had to, it was a paid subscription, and a bunch of us professionals were collaborating on that platform. And the problem statement was made by Dan Lindstedt, is asking, well, how is it that we can do or at least take advantage of Snowflake's architecture with regards to how we join tables together, right? So traditionally, MPP platforms like Teradata or Azure Synapse run on distributed keys, and hashing keys is a great candidate to do that because of the sort of randomness of the values that's generated from hashing. The distribution of the keys can flatten your data across your storage. Of course, Snowflake doesn't do that. Snowflake's MPP is totally different. So how is it that we can gain better performance in Snowflake by introducing or doing something with the modeling standards? So at that point, I made the suggestion of, well, why don't we use sequence keys? And it's not a new concept, which I'll explain shortly. It's just something that's been there already. But in my head at the time, I thought it would be less I/O to deal with and single column joins instead of the regular PIT tables. So to explain what I mean, dimension tables. So at least in the analytics space, we should all know what an SED2 type 2 table looks like. You've got your start and end date, you've got your natural key, you've got your attributes, the things that change about your business concepts. So in this case, a customer dimension. And you would have a sort of a helper column that's added to it. And in this case, it's a surrogate key, right? There's generally two types of surrogate keys in dimensional modeling. It's the durable key that retains the same value when the same natural key arrives in that dimension table, or you have a sequence key, which then starts to act like a temporal key because it's a record counter for your table. Every time you insert a record, it adds, right? So sequentially, it adds one value. So if I insert a new record, it's a totally different natural key, you'll get a new surrogate key because it's a second record. Platforms, especially like Snowflake, it's easy to define this key. You don't have to manage it yourself. You just, in addition of defining the data type, you define it as either identity or auto increment, and it does it for you, right? So these two records here are active because they've got the high date. And if there's a change to Dave, some values change to Dave's record, it'll still have the same natural key, but a different surrogate key, right? Because it's still counting the record. But that also means that, because it's a sequence key plus one, it's unique to that time period for that business object, even though, it's not specifically tied to that natural key, which is why it's not durable. It's unique for that table. So as new changes happen to Dave, the surrogate key is incremented plus one as it does. Again, you don't have to do anything. It's just, the platform manages it for you. If there's a change to Sarah, she gets surrogate key 5 because it's the next record that arrives, right? So this is super handy for dimensional modeling, because if we expanded this model and added a date dimension and account dimension, if you had a product dimension or orders dimension, and you bring in all that stuff together, basically what your or how your platform is engineered or your model is engineered is that these tables are defined first before the associated facts are brought in, because the fact table needs to know what that surrogate key is before it grabs it and saves it as the fact table itself, right? So what this means is if I'm looking for business data date flag Y, bottom right hand corner, basically it looks at all the records that are associated with that date. And because there's a single column, which is the surrogate key column, 4 and 1, associated to that customer dimension, it's a single column join, right? And that's it. It's an equi join. And you'll see later why this is really important, especially to an originally OLAP platform like Snowflake, is because we take advantage of a lot of these dimensional model algorithms underneath. So it's important to one, okay, it works with multiple columns, it works better with single column, but the equi-join really matters to a platform like Snowflake. So from a data vault perspective, if we would just change the naming a little bit, we would have a hash key, a hash diff, bunch of attributes, satellites, and instead of a dimension table, we call it an as-of table. It's kind of the same thing, but it's used to actually generate PIT tables. Because as a traditional PIT table works, you pick the start and end date as your managed PIT window, and then you generate the PIT table based on that window. So what happens is that the PIT table is generated, it's got the hash key and the load date that's applicable from that satellite table. So if you had to define a daily PIT, it'll grab the load date and hash key that's applicable from that satellite table for that business entity. So I generated like a really small example just to show you what it would look like. From the 9th to the length as an as-of date table, then it would take those appropriate keys for that point in time where those records are applicable, right? So going back to the original problem statement, what was my idea? Well, easily you could just add a surrogate key to the satellite table itself, which you do not manage at all. You just define it in your DDL as an auto increment column or identity column. And then as records are getting loaded, you got a sequence key that's incremented for every record that's inserted. And when you build in your PIT, instead of grabbing the hash key and load date, grab the surrogate key instead, right? So essentially, that's what it is. That's the big difference. And that's why it's called sequence number only PIT construct, because there's only sequence numbers in there, which magically sounds like a SnoPIT, and it does. So what I said earlier, there's a couple of things that happen when you build a PIT table structure, as well as if you're building facts and dimensions, is we're after that right deep join tree in your query plan. So what that looks like is in your query profile is you've got this profile that looks like this, right? So what Snowflake does in the back end, when you've executed this query, it looks at all the statistics around the table and realizes that your dimension tables are smaller than your facts, and it picks an algorithm for you. So I want to do a right deep join tree. So it does a build phase where it hashes every row of that dimension table or every row of that satellite table, and then probes that middle table, which is a fact table for dimensional modeling, but it's a PIT table for data vault, right? So without a PIT, Snowflake picks a left deep join tree or a little bit of a bushy tree. But as you can see, these are statistics that are gathered on running against 61 million records. Without a PIT, it's the network traffic between these cloud components, 121 gigabytes, right? Using the PIT, it's a tenth of the size. And using a SnoPIT, I've shortened that even more because I'm using integer data type, predictable integer data types. I'm using only a single column join. So if you had, because a hash key is got also incorporates not just the business key, but the collision code as well as the tenant ID. And a numeric ID in a SnoPIT does essentially the same thing. So it incorporates everything, but joins by a single key. And all these stats will run on an extra small warehouse, smallest one available. So from 11 gigs to 6 gigs, and the time is shortened by another 4 seconds, which on a platform like Snowflake, which charges you for consumption, in other words, for running queries, you could save a couple of queries or a couple of credits just using the SnoPIT structure. So a lot of this information is all available as QR codes. As I did a webinar earlier in the year explaining how to architect solutions, data vault solutions on Snowflake. So take out your cameras and your iPhones and take pictures away. There's also a blog series on a lot of these statistics and performance metrics that I ran to see what works on Snowflake. Things like which I was discussing with Peter just before this webinar, like probe side skew and that kind of stuff, and how to deal with it. So all of that is in there. And I think we're waiting for questions at the end, but I can answer questions in the QA and type while Peter's doing his portion of the presentation. All good.
Thank you, Petr.
Over to you, Peter.
I'm very honored to be here with Petr because a lot of his blog post is what we read before we started implementing stuff on Snowflake. We learned a lot. So I will share now how to implement this, because this was now very technical. And yes, you need to maybe understand in the background what is happening, but you don't want to build this from scratch. At least this is our assumption. So what is the Data Vault Builder about? The Data Vault Builder is a data warehouse automation tool. And we are partnering as well with Snowflake to optimize our tool, creating structures, managing structures, running loads on Snowflake. The tool as well tries to follow the Data Vault 2.0 standard. We as well in the certification standard with the Data Vault Alliance that we have seen, where as well these IDs are discussed on the web page. You can download comparisons to other tools, how we position ourselves, how happy our customers are. But as Patrick did it for Snowflake, I will skip through these slides very fast, that we can go to the technical implementation and have a look at the demo. The main thing is we're replacing really many different tools. So what we will see later on is while I model, the code will get implemented right away without writing one line of SQL. You can profile your data. We will look at that. We will not look at testing, but deployment is prepared. You can automate your deployment. Operations is built in. We will run already jobs during the demo to load different days of data to simulate such a temporal situation. Documentation and data lineage is happening. Everything is controlled by REST API, but we're explaining this kind of stuff in our longer presentations that you can register at the end. So what is the main idea that we will follow on? Is that we start with the business model. So we will take here the use case of a bank that has account statements and they want to report on it. They want to see how the account statements changes over time to see if there are any irregularities they need for legal reporting. So the business user sits together with the IT, they define what the target is. And now the IT profits from real-time implementation. They need to do less manual work. The business users profit that they see immediately the metadata, they know what is happening, they get the log files, they get really fast results. And this is what we will simulate now in this process, just with one core business concept, the account statement, but you can extrapolate that then for more data. What will happen layer-wise? Because what we talked about is that we have here in our core layer hubs with satellites, the satellites having this history that Patrick showed, and then we query this stuff. We need to bring different timelines together, and this is the difficult part from the business perspective. The account statement can have different changes than the account itself, and maybe the customer behind it, and now you need to do a temporal join between all this stuff. And the PIT table simplifies that, makes it more efficient to join different timelines together. So what we want to do is we want to stage our data, we want to historize it, and what we will do here as a special case, we will use a bitemporal history. So we will get the external timeline, which is quite common in finance, like you have an end-of-day processing, stuff like that, or inscription time in your source. We want to bring it in the vault. We want to add the load time because we need that for auditability to reproduce reports at a certain point in time. And as soon as we get bitemporality, our problems of the satellite gets even worse because we don't have only now one hash key and a load time that we need to use in the PIT table, but we have the load time and a second external timeline and the hash. So we have three attributes, so it makes the PIT table, the classic one, even more less efficient than the SnoPIT. Then we want to query that, but we don't want to be here like some data engineering god that writes really complicated SQL queries, and then we want to look at the data. So what we will see is that Data Vault Builder is a little bit different than other tools. So we don't have a modeling tool, a repository, and implementation, but in the Data Vault Builder, while we're modeling, the implementation happens in real time, making us really agile. This means that in the demo, we can see the results right away. We can test if everything is happening as we expected. The second thing is we deliver you patterns with the tool. So you just do the model and we can create different implementations over time. And that's what happened here as well. We created the first implementation of bitemporal data with classical PIT tables. We realized we're using too much performance. We're using too much I/O. So we looked around what could be a better implementation, found Patrick's description of it, tested it, found that it's more efficient, created new patterns for our clients. And what we always do as well, we create update patterns for our clients so they can update their physical implementation over time. So if Snowflake brings out new features that our clients can benefit from, they don't need to do anything then to upgrade to the newest Snowflake version, which is automatic. They can't do anything anyway. And upgrade to the newest Data Vault Builder. They get the new patterns, they get the update script, and they can use it right away. This saves time, but the main thing, it reduces your risk because you know you are in a standard way of creating stuff. This bitemporal stuff is really complicated to implement and test. And there are always edge cases that you didn't think of. And sometimes as well, we find new edge cases. And it lowers like this your maintenance cost over time. So let's jump right into the demo that we have enough time for this demo. So what is the storyline? And it's very similar to what we have seen in Patrick's example, but I have reduced it down to make it more understandable. We have only one single customer. This customer has only one account. It's his savings account. And we receive only one attribute, which is the amount on his account. I know it's a very, very simplified case, but at the basis, it's what is driving certain banking views. So what happens? We arrive, the data arrives the first day. It will be for the 1st of October, end of day statement, 1st of October. We will write into the satellite that this customer has on his savings account 5,050, whatever, because I didn't even include the currency. So let's assume whatever your local currency is. And we will write a tracking entry to say on day one, we have seen this value. And we will see in the next step why this is very important. And as well, this is very well described in the Data Vault Guru book in detail, what the problems are, what the edge cases is. So please go in this section to understand then the details if you're interested. On day two, the same value arrives. And now we get a problem. We could write this again into the satellite and say, yes, on day two, for day one, I have an entry. For day two, I have an entry. And it would work. The problem is if you do this for all your clients every day, even nothing changes, you write a lot of extra data. You use extra storage. You will use extra I/O when you will read the data. So you need to compress this data. So what we do is we say, we don't need to write this value. It's the same as the day before. So we don't write into the satellite, but we need to write into our tracking satellite. We have seen for our customer on day two a value. Because it's the same, we don't write a value, but we notice we have seen it. And it's really crucial. Otherwise, we lose the track of auditability. On day three, in my very simplified example, again, we get the same value. And the result is the same. We will write the information, not in the satellite. It's not new, but in the tracking. And now something happens, which is called a backward correction. So on day 4 or on load time 4, we get the information that the amount for day 2 was wrong. But as you maybe remember, we have written only the value for day 1. So if we would insert for day 2 just this value, then on day 3, we wouldn't see the 5050, but we would see the 6050. And here now the tracking satellites helps us. It tells us, hey, we haven't written these values, but we know they were identical to this. Now when this value, this backward correction arrives, we know we need to sort it into day 2, but based on the tracking satellite, we need to inject a new value for day 3. And you see already how complicated this is with one customer, with one account. But if we find a pattern to solve that, it will solve all the issues. Now, the point is that for identifying the different entries, we have the hash key on the satellite, we have the processing time, and we have the day when it was valid. So it's a bitemporal satellite. And joining on 3 columns from a PIT table to a satellite becomes, on every database system, less efficient than joining on 1 column. It can be just a small difference. It can be a big difference depending on your database system, but there is usually, the database need to do more, and there is no magic. So by replacing it with a single integer value will reduce the amount of work that needs to be done. So let's jump here into our data vault builder. It's a browser-based tool, and I really start from scratch. So the first thing I need to do, I start with my business model, and in that case, it will be very simple. So I create an object for the account statement, and let's put that into the finance section. And this is my concept. And I discussed it with my business user. I discussed how the account statement should be stored. And we would probably model a little bit more. For this example, I create only this one core business concept. So let's go now to the staging area. And I have here already some different data sources, but I will filter this down on a new source that I want to create. So I will call it financial data, FD. And as connection, I have prepared a SQL Server. As you see, we have here many built-in connectors that we can connect from. We can use the built-in Snowflake staging mechanisms already and just access it through ELT. But in that case, I want to access just my pure SQL Server here in my local network. But this is the source. The target where the data will be stored is a Snowflake database. So I'm creating in real time then objects like target tables, load statements, and everything in the Snowflake database. Now, to simulate several days of load or exports, I have created different databases, but this is really only for the demo. You would have here one database loaded daily, or you would receive files and load them on a daily basis. Or if they're resent, maybe several times a day. Good. So after creating our connection to our source, let's load our incredible source data. And I placed my object in the famous DBO schema, and I have here my account statement. And we see here, it's a very reduced table. And what I did here is already, I asked my source to use a certain convention here to use the extraction time or the end of day time here in a special defined way that we use in the data vault builder called CDC inscription time. But I could have renamed the column if the source didn't do that for me already as well here during the staging. But to simplify the demo, I already prepared the data as much as possible. So we select the customer ID, the account, the amount that we will store in the satellite, and we have the date for which this amount is valid. I skip everything like delta loading, and now it will implement everything right away. So it creates the staging load, it creates the target table, it adds everything to the documentation, and starts loading the data. And yes, that's not very big. So if we look at the data, we get now the customer AB 20045 for his savings account, and we see the amount that we want to load. And it will be always the same customer, same savings account. So now we need to load that into the data vault. And because I already have one column marking me the external timeline by convention, by having a specific name, it recognizes that this is a temporal source. So we can load that directly into the target. And you see that now this temporal column is not here because it will be automatically handled by the tool. So let's select just as business key the customer ID and his account. And because we're working in real time with the database, we can query the Snowflake database and we see directly what the business key looks like. That looks very fine. And yes, we need to combine it because the customer could have several accounts. And we could do more settings. We skip all of that. And now let's add a satellite as well here. And it would be enough to just add the amount. But just for convenience that we see a little bit more in the satellite, I add the customer ID and account as well here. Usually I would create links to this kind of object, store it there. Really simplification that we put all of this in one satellite. And that is it. Everything that Patrick explained in the background, that we create a satellite with an ID, that we create a load statement to use identity to load it, happened everything automatically in the background. So we have these two different levels. Yes, we need to understand how to optimize everything that Snowflake can work very well with it, and other databases, by the way, as well. And the second part is we should make it so simple for the business user and the data engineer that they don't need to think every time about the details. So we have now a production-ready implementation here of the hub. So it's a core business concept in the model, but in the background, we have a hub created and the small dot is our satellite. So right away, we can start loading. It will modify the staging table to include the business key and hash key pre-calculation, load everything. And a few seconds later, we should get our first bi-temporal satellite, including the data, and it will have the sequence number that we expect. So we have here the hash key, customer ID and amount, that we see that, the amount. And now what we see here is this ID. So this will be the key that we will be using in the PIT table. Additionally, we have here two information. This was valid as of the 1st of October, but it was loaded right now. So you see here, I'm in Zurich, so this is Zurich time. So it's fully auditable that this information was loaded several weeks later. So if I need to recreate the report as it was yesterday, I could say I haven't seen this information yet. Good. So the next thing is what we need to do is we go and we create an output interface. And here in that case, it will be very simple. It will be at the grain of the account statement, financial data. I don't need different functions. And here I selected I want to output SCD type 2. And this will tell, just this dropdown tells now, create a PIT table in the background. And as we know what is efficient, we will create here this SnoPIT in the background. You don't need to do anything. You just need to let it do its work. It creates the table. It creates the load statements. It updates as well the operations job. It updates the documentation. So again, we're production ready. This table is right now empty because I haven't loaded yet the PIT table. Even I have data in the vault, the PIT table is empty. So let's go here into our operations module. And automatically, while I'm modeling, in the background, a job was created to load this data, to process everything. So let's just start it. It will stage the data, it will load the raw vault, and as well calculate the PIT values. Yes, we're loading one row, so it's not like magic, but I'm doing that you can follow how the data changes over time. So if you look now in the result, so this is exactly what we get. And I didn't add any attributes to the output. So that's why we don't see anything. We just have seen the load time and the load time end. So let's store that again with the attributes. Let's reload the PIT table because now we need to add new satellite into the PIT table. And now we see our first entry. So on 1st of October, this customer had the amount of 5,500. And this is already using in the background the SnoPIT. So let's now load the next day. So I go in here and I change the source to load the data from the second day. Let's simulate the second day. And what I expect now to happen in the satellite, as the amount on day 2 didn't change, we will have only one entry in the satellite. In the tracking information, it was already stored that we have seen day 2. I could put that in the output, but on purpose, I'm not doing that. I go just to my data viewer to visualize it here a little bit better. And let's take the bitemporal table. So let's see what we see here. What we see here that our customer with our savings account for this record, he got only one entry in the satellite with the business date of the 1st of October and the load time of the 25th. So this is the same as we have seen in the core. And we will see here the change in a second when I will update this as soon as we do a correction. So right now we have loaded day 2. Let's load day 3. On day 3, still nothing changes. And now after the 3 days, let's refresh here our satellite view. Still no entry, only in the tracking satellite. The information was stored that for day 3, we have seen the information. And now on day 4, we receive a backwards correction. For day 2. Let's do that. Let's start a load. And you see, I didn't code anything. I just defined what my thing is that I want to do, the interface I want to see. And now if we go to the data viewer and we look at the bitemporal satellite, we don't see only one new record, but 2 new records. Why? The system realized, based on the tracking satellites, that the value changed for day 2, but as I didn't send a correction for day 3, it still needs to assume that on day 3, the original value was correct. So now we have 3 entries. We have 3 different identifiers. So if we go and we look now how the view looks for the receiving system or for the reporting system, let's sort it by date. Automatically, it created out now the nice history of every day with the changing values automatically. And you haven't seen the SnoPIT here, and you haven't seen the satellite in detail, the load statements and everything. And this is exactly the idea. We use it automatically to make the right thing. So what does it help at the end? We have replaced the hash key with 2 timestamps for querying with 1 single identity column. And we don't need to even use the hash key anymore because every row has its single record. So we can go jump without the hash key, without the timestamps directly to the right row in the satellite. And yes, for 1 row, honestly, it will make no difference. So what does it help? But in the next slide, I will show a bigger data set. And what does it help as well? The nice thing is that we now have an identity sequence that we control. We can add as well here the record for the ghost satellite in this integer. So we don't need to have a separate column to identify if we link to the ghost record or not. We can just use record 0 or 1, whatever, and then start sequence 1 higher to link to the ghost record. So I did the same test, and I used here some TCP data, and I used 15 million records and not only 15 records, otherwise it would be a little bit weird. And I joined several satellites, and I compared now the same as Patrick did in the beginning without SnoPIT, so meaning we used a normal pit and compared it with the SnoPIT. For our queries that we did for testing, it took 34 seconds. And please don't take this here as a real figure. I used a much too small warehouse to do the queries on purpose because I needed to get some measurements that are long enough that I know that they are not like fluctuating times. So that was on purpose. It took a little bit longer, but still the same query using the SnoPIT took considerably less I/O, less space, and was faster. So is this really a fair comparison? No, it is not. Because for my without SnoPIT, I used only a unitemporal satellite, and for the SnoPIT, I used a bitemporal satellite, because for the SnoPIT, it doesn't matter how many times you have in the satellite, because it behaves always the same. So it scales much better the more times you have. So it was faster, even it was doing more. And as well, I did single row queries just to compare it. And yes, if I go down to a single row, it can, the difference is maybe smaller, but we see it here really. I separated all the accounts that one Clark is managing, and it took without the SnoPIT 2 seconds, and it was just a little bit faster with the SnoPIT, but still it was faster, and it accumulates, and it every time saves you something. So this is what we believe helps you in the long run. So let's have a look at the questions. So one question is, are SnoPITs new in Data Vault Builder, and from which version on? Yes, they were not always there, and we are using it mainly now for the bitemporal satellites. So from the version, I need to look it up in the release notes where we introduced bitemporal satellites or the CDC process. You will use as well this kind of SnoPITs. We didn't change it yet for classical satellites, because the effect is still there, but it's much smaller. And so we are still evaluating for all the database systems if we shall change it, because it would be a big update. So this could be something for a major release then to change it. But already for bitemporal satellites, it's using this new pattern. One question is, how is the orchestration done from the source to the target? And this is something that we do in the Data Vault Builder itself. Based, if we go back here, let me check if I have a slide in here. No. So let's go back here to this view. The Data Vault Builder sits as orchestration tool over all the layers. So based on the different model parts, it knows what the dependencies are, and it will trigger the corresponding loads. Now you can use in the built-in scheduler to do that, or you can use the REST API to externally use UC4, Chronicle, or Airflow to trigger this kind of jobs. Or if you like, you could, on the granular level, control all the single loads as well yourself, because they have a REST API as well, but that's not recommended, because you wouldn't need to then evaluate all the dependencies and everything, and that's what we do already for you. Any more questions?
Yeah, I mean, just if you're doing SnoPITs, it doesn't change anything on Data Vault Builder, I assume. It's the incremental columns are handled by Snowflake. So it just goes +1, +1, +1. So I imagine it doesn't do anything for you until the end when you select the sequence ID instead of the load date and the bitemporal columns.
Exactly. There's one good question that you already answered, is when should you update your PIT? And yes, it depends. It would be probably my answer as well. Out of the box, what we do is after a load that impacts the PIT completed, like a raw vault load that the whole system completes, we would update it. If there are several systems running in parallel that impact the PIT, we would wait until both of the loads complete to update the PIT only once. But still, you could manually trigger it as often or as not often as you want by then changing the standard configuration. But out of the box, usually after one source system updated, satellites involved in the PIT or the hub involved in the PIT, we will update it, because that's our assumption that this is the last step.
I mean, it's conceptually, as you say, it depends on what you're trying to report on. You wouldn't update a PIT all the time. It's only, I need to know what my data looks like Monday morning, 9 o'clock. All right, then you need the keys for that period. That's it. That's what a PIT's for.
And then the question as well for different SnoPITs, what we do usually out of the box is that we create for every hub, which has a SCD type 2 output, we create a PIT. So if somebody's just outputting like SCD type 1 information, we have another way of optimizing it. We do already a small index while loading the data to point always to the latest record. So we don't do that. But if a hub is involved in a SCD type 2 output, for every hub involved in this kind of output, we will create the PIT, and only for the satellites involved in the output. So we don't have like a standard pattern, always include all satellites, but we really look based on your demand, what is in your output, and only put that in the PIT.
Yeah, there's a question about hash keys. You don't have to. In fact, natural keys are probably faster, a lot of use cases. It also depends, because it's what we pointed out earlier. What you have to consider is not only the size of the tables, but the algorithm that gets used, but also the network traffic, because this is all basically wrapping up cloud infrastructure for your database. So if you're happy to use just natural keys instead of hash keys, go for it. It's probably faster. Hash keys are great because if you're not using the PIT and you're joining tables together, it's only a single column join as well. But then you have to consider the temporal aspect, as we pointed out, like the load dates, supply dates, and business dates, and so on. But it also encapsulates, if you're using business key collision codes and tenant IDs, because a hash key can be made up of not just the business key, if it's composite or simple, but also if you're trying to load to the same hub table and you have two business keys coming from different sources that might actually represent two different entities, then in Data Vault, you add a tiebreaker value to say, okay, so it will only load, it will load it uniquely into the hub table. You'd have one with a tiebreaker value and one without. And then you have the hash key that's based on it, and use that to join instead of the natural key. But if you're more than happy to join by natural key plus business key collision code, then go for it. It's not mandatory that you should be doing hash keys on Snowflake. Definitely not.
Yeah. So from my side, we did for some clients the evaluation, what would be more beneficial. And honestly, there is not so much difference as you would think of if the database is anyway optimizing and replacing the values by pointers as Snowflake does. So does it use more or less space for certain joins because you need to put then the business key in all the satellites? Depends on how your business keys are. If they're really short, yes, it looks beneficial in the beginning. As soon as you go in the direction of transaction, which have a compound key of several fields and are the big tables, it doesn't look that beneficial anymore. So the answer,
yeah, it's an excellent point, because in my earlier testing, I was quite generous with my business key value that I generated, which in Snowflake compresses very, very well. So it will be definitely smaller than the hash key because of the natural compression you get on Snowflake, because it's files that's being compressed and UC tables. So yeah, excellent point, Peter.
And as well, it's always what we're saying here. What we are doing here is not changing the logic of Data Vault. That's important. It's behaving exactly the same. It's just making the technical access to certain elements in the Data Vault more efficient. So for me, this is still within the Data Vault standard, as it's like an index column that you would put on a table which is hidden. And here we just make it visible so we can more explicitly access it, and it's stable and it's not changing like a row number or something. So it's not like we're changing here anything drastic. It's just really to help you to access your data faster. That was already there, exactly managed as before. That's at least my point of view.
You got a question there from Bjorn.
Okay, but what is when the 6,050 from day 2 was correct and day 3 and following days are 6,052? How can I handle that? I need to load the third day and the following day again. Usually, yes, because that's in fact what if you really do bitemporal load and it's coming from your source system, it gave you for 2 days the wrong information. So it means that it needs to give you the correction as well for both of the days. Now imagine that it did already only send you the value on day 1, and because there was no change, it didn't send you a change on day 2 and day 3, then it would be fine because it only claimed on day 1 this value. If you then load day 2, it would be valid from that point in time into the future. But it is correct in a bitemporal load, if the source sends us wrong information for several days, you need to get the correction as well for several days, otherwise it doesn't work out. You could still write a business rule saying if there is a correction and you would recognize it based on the load time and stuff like that, that you want to apply it to the future days because you know better than the data that you see. That would be fine, but usually it's not recommended. One question, do you apply the same bitemporal logic to links as well? Yes. You have to. And as well, then if you join several hubs into one object, we will as well create 2 pit tables and apply the logic between the 2 pit tables to evaluate correctly what happens. And what we do to make this work is that we include the many-to-one links as well in the pit table, because we know there can be only one value. So we can, in the pit table, reserve a column for this kind of relations.
Yeah.
Good.
Almost 8 o'clock in the night for me.
And so for me, really important is there are 2 aspects. One is technical aspect. And even if you don't use the data vault builder, please read the book by Patrick, because it gives you a lot of insight, not only in this topic, in many other topics. And even if you're not working on Snowflake, it still gives you the insight. It will give you the insight into edge cases that you maybe didn't thought about it right now, but that you will encounter in the future by definition, and learn from it. And if you want to then automate this kind of stuff, because you say, yes, I understand that this pattern thing and how you do stuff and how you store stuff is important, but I don't want to deal with it. I want to deal about my business. Then book a demo with us and we can show you how to automate this kind at a higher level and still in the background profit from this kind of people working really on the technical details. So there's one more question, but is this example really bitemporal? You only use CDC inscription time, extraction time, and yes, load time, but this would be not matter in real cases. Okay, sorry if I already answered this part. If I have legal reporting in Switzerland in the financial sector, it matters to me because I need to be able to reproduce reports as of a specific day when I generated them. So if I generate a report for last year at the 6th of January, I need to be able to reproduce it again and again later on, even if it's already the 30th of January and I know that what I reported on the 6th of January was not correct because I got corrections in the meantime. Now, let's go further, but it can be that in your business, it's not relevant. So I not want to talk about that your point is not valid for you, but in the real world, there are cases where it is. In your source, I saw an effective date, the real business date validity. Did you not take that into the data vault? In that case, I just used the effective date as my inscription time date to process it automatically. Usually in a real world case, I would get the effective date named with the effective date and I would mark it in my staging table as the external timeline. Just for the demo simplification, I already created an alias in my fake source system that I have one step to do during the demo that I don't mess up too much stuff. In my opinion, for bitemporal, you should have used CDC inscription time and effective date. Can you handle this as well? So as I say, in my fake example, that was the same. If there would be a business validity additionally, like it would be like a contract or a policy in the insurance business, I would have used that for the business key of the hub. So I would create like a policy instance hub, and then I would have access to all the instances, because still I get like a new instance of a policy like for the next year. It doesn't mean that the old one is replaced or invalid. It's just for a different point in time where it is valid. So I want to access it, and if now a claim comes in, I can link it to the correct instance directly to the hub. It's not like everybody does it, so Patrick can maybe comment how he does it, usually model it, but that's how we recommend it. So I would have in my model a policy and a policy instance or policy history hub, and one would be at the grain of policy number and the other one at policy number plus the business valid from date. Patrick, if you want to comment on that.
Yeah, I mean, it depends. Like any IT answer, there's multiple patterns on how you can deal with that. You could have absolutely a policy hub, but you can also load dependent child keys in a satellite to track those independent instances of the policy. That's also alternative, but it's not a strict rule. It's like, okay, what works for you? And really importantly, because Data Vault are not known for this, how is it that it's sufficiently to get the data out as well? One of the most underrated activities, in my opinion, of Data Vault is satellite splitting. So getting the grain right at your Data Vault will save you consumption credits getting the data out. So it really depends what your data looks like as well.
I agree with you. I know there are people that storing it really as a multi-active satellite, different versions based on the business date. From my experience, I stopped that because then I can't address anymore in the model. I could still do it in the business rules, but in the model, I couldn't address a specific instance. And usually if I have claims or something against these different instances of the contract or the policy, I couldn't express.
I mean, I think at a current customer right now, I've been there for 1.5 years. And a few months ago, I said, we think we should make a multi-active satellite in this situation. I said, no. Do a satellite with dependent child key instead, because this is the outcome you're going to get. And then they say, I want to see what the code looks like that's generated from multi-active satellite. Okay, so they had a look at it. Yeah, we don't want it. So in 18 months, we haven't used it. We went with an alternative pattern because it gives you a certain view of the data that unbeknownst to a lot of modelers and developers is that although when you hear the sentence, we need multi-active records for a certain instance, they think, multi-active satellite. It's good for sets, but you rarely see that. So yeah, I'm probably in the same boat.
Just disconnected from this discussion. What I usually recommend people on Snowflake, if they want to do multi-active, to say no, do instead a variant column, do a JSON aggregation of your values.
That depends. I mean, that depends as well. There's an interesting pattern I'm looking at now. See how that fits into Data Vault is activity schema. And they've done something similar where they've broken down things into a business vault satellite, into activities, and then the payload they've kept in a JSON column, where it's got the variations of all the details about that activity. So that looks interesting. It's kind of like a multi-active, sort of.
Yeah. By the way, the one that asked the question is saying interesting point. I will think about it. So if you want to think about it more, if you go to my blog, after you've read Patrick's blog, there is a whole series about bitemporal stuff. And it is really exactly taking you through the different variants, how you can model stuff, and what everything can be done, what are the options, how you can reduce complexity. That's always my thing. What I would recommend as like my last word here in this webinar is think about, do you really need some kind of complexity? I mean, we talked about bitemporality, we talked about pit tables, and yes, that's relevant for a part of us. But for many people, there could be a simpler way to reduce your complexity already while loading or while querying your data, and maybe not to go into such complex report if it doesn't provide you any business value.
Yeah, keep it simple.
Good. I think that was really nice. Thank you a lot for all the questions. And thank you, Patrick. It was really a great honor to have this webinar with you. And looking forward to meeting you again.
Nice to see you again.
Yeah. Thank you for everybody that joined the webinar, and have a nice day.